Hi everyone and welcome back. I hope you guys all had a great Thanksgiving break. And now we're here in the second to last week of the semester. So really in the home stretch now. And the topic for today's lecture is going to be measures of association. Specifically, we'll be talking about chi-square tests and correlations. And what both of these do is they give you information about whether one variable is related to another variable. And we'll talk about what that means also. Before I do that, though, I just want to go through the schedule for the end of the semester. So this is the same slide as in the last lecture, but just with a couple things deleted here. So we have this week, which is week 14, where we're going to be talking about the chi-square tests and correlations. This week, problem set number 12 is going to be due, and if you remember, that is the last required problem set for the course. Week 15, which is going to be the week after that. The topic is who cares about statistics? The answer is me, but we're gonna talk about some applications and just things to look out for if you're ever reading anything statistical or watching the news or stuff like that. And on that week, you'll have an option to do a makeup problem set. So if you missed any problem sets over the course of the semester or got a bad grade, you can do this makeup problem set to replace your lowest score. And then finals week, nothing. There's no more class. So we're not doing anything finals week. There's no final exam. There's no problem set or anything like that due on finals week. Once you complete your last problem set next week, you will be totally done with the class. All right, so with that, I'm going to get into the content for today. And so this is going to be our last bit of actual statistical content. And next week, as I said, we're going to talk more about sort of applications of everything we've been learning. So chi-square tests are all about looking at relationships between two variables that have nominal categories or categories that can otherwise be put in a crosstab like this. So a crosstab is a frequency distribution for two variables. And I'm going to show you what it looks like in a second, but first a definition. An observed frequency is the number of observations that you have in each cell of your crosstab. So here's an example of a crosstab. It's like a frequency distribution, so we're listing the values or attributes of a variable and the number of the observations that we see for each one. The difference here is that instead of only showing the number of the observations for each value within a single variable, we're going to look at the number of observations that fall into categories for two different variables. So these are questions from the class survey. One, as you might remember, was, would you rather kill someone and have no one know, or kill no one and have everyone think you did? Another question on the class survey was just, what's your gender, and whether you said male or female. So what you can see in this crosstab here is that in this class, 6 people said that they were male and that they would rather kill someone and have nobody know than kill no one and have everyone think they did. 10 people said that they were female and that they would rather kill someone and have nobody know than kill no one and have everyone think they did. The bottom row there, you can see of the males in the class, 13 said they would rather kill no one and have everyone think they did, and 11 females in the class said that they would rather kill no one and have everyone think they did. So when we talk about a relationship between variables, we're talking about whether there's any pattern of results in how people responded or in how the observations are distributed across two different variables. So a little bit more concretely, if there was a relationship between these two variables, so if there's a relationship between gender and whether you'd rather kill someone or kill no one, we'd be saying that, people who identify as male or female, like that's going to have different have different responses to the question. So either we'd be saying that males are more likely to prefer to kill someone and have no one know, or females are more likely to say they'd rather kill someone and have no one know than kill no one and have everyone think they did. So if there's a relationship between these two variables, we're saying that responses on this question are different for males than they are for females. So they'd be related because, something about being male or female would give us information about what the response is most likely to be on the question. So responses on one variable are somehow related to responses on another variable. Before I get into that, though, I need to talk a little bit more about this crosstab and its different parts. So on a crosstab, you have your main cells, which are the ones with the observations in them that we just went through. So one cell has 6 observations in it, one cell has 10 observations, one cell has 13 observations, and one cell has 11 observations. So those are your cells and your observations. We also have what we call marginals that I've now added to the crosstab in that column on the right and the row on the bottom. And the marginal is the sum of cases in each row or column. So if you look at that top row there where it says kill someone and have no one know, 6 guys in the class gave that answer, 10 ladies in the class gave that answer, and in total of people who responded to this question, 16 people gave that answer. If you look at the row below that, 13 males in the class gave the answer that they'd rather kill no one, 11 females in the class gave the answer that they'd rather kill no one, and so 24 people in total gave that answer. So that's what we would call the row marginals, because that's the total number of people in each row. We also can have column marginals where we're adding down the columns. So here in the class, there were, starting with the column labeled male, we had 6 males in that first cell who said they'd rather kill someone, 13 males in the second cell who said they'd rather kill no one. And so if you add that together, you have 19 males total in the class. So for females, we had 10 females who said the first answer, 11 females who said the second answer, and if you add those together, that means you have 21 females total in the class. Finally, if you either add up your column marginals or add up your row marginals, you'll get the total number of people who responded to the question. So if you look at that last column there where we have a 16 and a 24, if you add up 16 and 24, you get 40. So 40 people said that they would, either kill someone or kill no one, right? Those are the only options. So 40 people responded to the question, and we can find that by adding up the responses to the only 2 options we have. Same thing looking at male and female. So those are the only 2 options that you could give. So if we have 19 males and 21 females in the class, we have 40 people total who responded to the survey. So those are your marginals, which again you get by either adding up either across the row. So 6 plus 10 is equal to 16 in that first row, or down the column. So 6 plus 13 is equal to 19 in that first column. All right. We can also add something called relative frequencies to the crosstab. And relative frequency here has the same meaning that it did in a regular frequency distribution, where we're just saying the percentage of observations that were, each attribute of the variable. In this case, though, you have to choose whether you're going to find percentages for columns or for percentages for rows. In the example that I have here, I have the percentages for columns. So we would call these the relative frequencies for the columns, or column relative frequencies. And so what you can see here is that of the males in the class, 32%, or 6 out of 19, said that they would rather kill someone and have no one know than kill no one and have everyone think they did. 68% of the males in the class said that they would rather kill no one and have everyone think they did than kill someone and have no one know. We have 100% down there with that 19 in the first column because we're only calculating these percentages for the males in the class. So there are 19 males in the class, and that's 100%. If you look at the female column, we have 10 females who said that they would rather kill someone and have no one know out of 21, and that comes out to 48%. So 48% of the females in the class said that they would rather kill someone than kill no one. On the flip side of that, you have 11 out of 21 females in the class said that they would rather kill no one and have everyone think they did than kill someone and have no one know. So we've got 11 out of 21 there, and that's 52% of the women in the class gave that answer. So again, you have 100% in the bottom there because we're just tallying up everything in that column. So there are 21 females in the class, so that's 100%. You can also find the relative frequencies for your marginal columns as well. And so what you can see there is next to the 16 we have 40%, and next to the 24 we have 60%. These are the percentages for everything in that row. So 16 people in the class total said they would rather kill someone and have no one know. So 16 out of 40 people who answered the question total is 40%. So 40% of the class, regardless of gender, said they would rather kill someone and have no one know. 60% of the class, regardless of gender, said they would rather kill no one and have everyone think they did. And then again, we have 100% at the bottom there because now we're just looking at totals, and 40 people is 100% of the class who answered this question. Sorry, who answered both questions. So what you can see here and why this is useful is just at a glance now, it's a lot easier to compare the two categories. So in this class, 48% of women would rather kill someone compared to only 32% of men in this class. 68% of men in this class would rather kill no one and have everyone think they did, compared to only 52% of women in this class who said they would rather kill no one and have everyone think they did. So in this class, our women are slightly more murdery than our men, based on this crosstab. All right, so what we're going to be doing with these crosstabs and where the hypothesis test comes in is we want to know whether there is a relationship between these two variables in a broader population. So here we're talking about you guys as a sample. So we'll say that our population is criminal justice students at Rutgers. This is a required class. So you guys are probably a pretty random sample of criminal justice students in at whatever point in the program you take this class. So the question here would be, based on this crosstab, do we have evidence that in general female criminal justice students are more willing to murder than male criminal justice students? And in order to do this, we're going to do a hypothesis test to see whether it's possible that the distribution of findings we have in this crosstab could have happened just by chance, if really there's no relationship between gender and, preferring to kill someone and have no one know rather than kill no one and have everyone think you did. So in other words, we're going to be using this hypothesis test to say, based on a sample crosstab like this, do we have evidence that there's a relationship between the two variables we're looking at in a broader population? Or is it possible that, gender has absolutely nothing to do with how people answered this question, and we just happen to have a class here where the women in the class are more willing to kill someone than the men, but it's totally just by chance. So we're going to be answering that question with a hypothesis test. In order to talk through the hypothesis test, though, I have to give you one more definition, which is something called the expected frequency. And the expected frequency is defined as the number of observations you'd expect to have in each cell if there was no relationship between the two variables. So in other words, if gender has absolutely nothing to do with people's, preference for killing someone and having no one know, or killing no one and, having everyone think they did, if there were truly no relationship between those two variables, how many women in the class and how many men in the class would we have expected to answer the question in each way? So I'm going to hop over to the document camera now. There's a pretty simple formula for calculating this, and then I'll show you what the expected frequencies actually would be for this particular crosstab.